Okay, let me go ahead and give me a second, guys. Hold on. I want to make sure that my oh crap! I need to change the. What is it called? I need to change the title of this because it's not right. Hold on. Or actually, no, it is right. Or no, never mind, it's not. I'm joking. It's part 2, never mind. It's, because this is a stream, it's not a video, so it should be, it's part 2, never mind. It's, because this is a stream, it's not a video. Okay. I just want to make sure it's working correctly. Okay, so let me go ahead and get started. So, yeah, this is a really random time of the day for me to be doing this, but I thought, why not? So, I think in the last video, because I made a video, but the problem was, or a stream yesterday, but the problem was that I kind of messed it up because I put mute, and then when it muted it, or when I think when I unmuted it, I think, was when it actually, kind of got messed up, because the thing is I have YouTube open for live, like the live thing, I have it open. So yeah, but anyways, we're gonna get started. Okay, so let me see what we put. We were doing what were they called? Rational functions. So I think I just went over the introduction of what a rational function was. So if I'm correct, and let me just look at the description again because I really don't want to mess this up. Okay, so first things first. The first thing we're going to look at is, and let me try to write that bigger. Oh my goodness. I don't know why, like, rational functions. Okay. Now, the one thing I'm going to teach you guys first about this, which was something I forgot to cover yesterday when I streamed. I know yesterday, that's why I'm redoing the stream, because first of all, the sound wasn't right. Second of all, well, yeah, I mean, I saw part of it, and I saw that there was an echo. So, let me just go ahead and, for rational functions, there's a specific form. Okay. That's the, I wouldn't say it's the vertex form, it's the form of a rational function. I'm just gonna say that. But this is when you're shifting. So like, for example, if I have right? Something like this. And I have a rational function, so if I have something like basically the most basic rational function, right? And let's say that I'm shifting. So basically, this part is h units, and then this part is k units, okay? So if I say, for example, 1 over x minus 3 plus 1, it would be 1, 2, 3, 1, right? And we'll do 1, 2, 3, 1. So it looks something like this. And then you do the same thing for here. You do 1, 2, 3, 1. Something like that, and then you would do, basically you would do something like this. Okay. That's how it would be. I mean, it's hard, it's a little hard to explain. It's like shifting functions. But usually there are some that they won't give you exactly in this form. So this form is kind of underrated, if that makes any sense. Like you would only use it, like it's not used as much as when you're actually, like, unless you're shifting a function, you know, or describing the transformation of the function, you wouldn't really, what is it called? Like, you wouldn't really be, using it as much. And let me actually, hold on guys, I'm gonna get something really quickly. This is just so that I can verify that the stream is working right, so that the sound is working right. That's kind of why, let me see, hold on. Okay. Okay, perfect. Okay, so yeah, usually they're not gonna give you something like this. They usually give you more, so a rational function, I'm trying to think. This would be the, well, they call it the vertex form. But I wouldn't say it's a vertex, because where would the vertex be, you know? That wouldn't make sense. The more common form that they would always give you is f of x equals ax plus b over cx plus d, such that a does not equal 0. And also c does not equal 0, and cx plus d does not equal 0. Okay? That's how it works. That's the common form of a rational function. You wouldn't really, you wouldn't use this other one. This other one, you would only use it maybe if, you would only use it like if they give you something like if they give you a problem like 1 over x plus 1 plus 6 or something like that, and they're like, oh, go ahead and add this, then you could say, oh, this is of the form 1 over x minus h plus k, but then you wouldn't really have to use it for anything. You would just note that that is the form. So I really just want to make sure we understand the difference between this form and this form, right? So I think in the last video, or I don't know if in the last stream that I did, I went over vertical and horizontal asymptotes. I'm going to go over them again. Just very, very, very quickly. So, or actually, let me first do, so let's just look at the difference between 1 over x, like y equals 1 over x. So obviously if we do it, right? So, so we have 1 over 1, right? And then we do 1 over 2, that's like 0.5. 1 over 3, it just keeps going further and further and further to 0, right? But it never touches 0, okay? So then we do a curve like this. And I can always do a XY table, right? If we do, let's do up to -4. Okay. So if we do up to -4, so -4, -3, -2, -1, 0, 1, 2, 3, 4, right? And if we look at, for example, 1 over -4, that's approximately equal to, I think it's, oh god, what is it? -0.25, right? If I'm correct. So it would be like right here, like around here, you know what I mean? And then 1 over -3, that's, I'm trying to think. So it's, okay, hold on. I'm thinking. It's because I don't know off the top of my head. It would be, so basically 1 over 2 is 0.50. let me see, 1 over 4 is 0.25, I was correct. 1 over 3 is 0.33, so basically we have negative 0.25, and then negative 0.33, and then negative 0.5, and then negative 1, and then this is undefined, because 1 over 0 is undefined, right? And then we have a 1, and then we have a 0.5, and then we have a 0.33, and then we have a 0.25 for x equals 4, right? Because, I mean, if you look at this as like a fraction, basically, and you can, but at the same time you have to understand what the decimal is so that you can graph it, right? So this would be, so basically, so y in fraction form would be negative 1 over 4, negative 1/3, negative 1/2, negative 1, and then for 0 it's undefined. For 1 over 1 it's 1. And then 1 over 2 is 1/2, 1 over 3 is 1/3, 1 over 4 is 1/4. Okay. So if we plot those points, we have negative 0.25, and then we have negative 0.33, negative 0.5, and then we have a negative 1 right here. And then it's undefined from there, so basically we just go ahead and draw the curve like this, right? Now, I'm going to get a different color, and I'm going to do negative 1 over x, okay? Let me go ahead and move the board. And, I mean, we don't have to do a time or a XY table. We can, but I'm going to have to erase this one. Let me first do the XY table. So, for negative 1 over x, it would be, so we have negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3, 4, right? Okay. If we do y equals negative 1 over x, if you guys hear noise in the background, I'm sorry. They're being kind of loud. Hold on. I might as well not use this marker because it's kind of dry. Oh my goodness. Hold on. Give me a second, guys. So if we do negative 4, we say negative 1 over negative 4, that's basically 0.25, right? Negative 1 over negative 3, that's 0.33. Negative 1 over negative 2, that's 0.5. And then negative 1 over negative 1, that's 1. And then 1 over 0, that's undefined. And then 1 over negative 1 over 1, that's negative 1. Negative 1 over 2, that's negative 0.5. Negative 1 over 3, that's negative 0.75. Or sorry, negative 0.33, excuse me. And then negative 1 over 4, that's negative 0.25, right? Oh my goodness, they're being very loud. I'm sorry, guys. Oh my god. They're being so loud. So, okay, so, this, okay, so the graph we have 1, so basically 1 over negative 1, that's negative 1, obviously. 1 over, what is it? 1 over negative 2, negative 1 over 2, that's negative 0.5. Negative 1 over 3, that's negative 0.33. So it's just going to go like this. It's going to get closer and closer and closer and closer and closer and closer to 0, right? And then for 0, it's just undefined, so we just draw the curve like this, right? And then for the left side, negative 1 over negative 1, that's 1, so we have this point. Negative 1 over negative 2, that's 0.5. Negative 1 over negative 3, that's negative 0.33. Negative 1 over negative 4, that's 0.25. Negative 1 over negative 5. Well, yeah, basically. So it's going to look like this. Okay. So if you see the difference, this one is going like, so this one goes, if you look at my marker, goes like this. So the 1 over x, if you just do a sketch, it's like this. And this is not drawn to sketch, but you know what I mean. And actually, let me put that in. Let me put that in the marker that I put it in. So 1 over x is like this, right? So that's 1 over x, right? Negative 1 over x is this one here that we just did. And it's like this, right? You have to know the difference. And if I draw the coordinate plane, this is just going to be a sketch, right? If I draw the coordinate plane for both, right? I should have done it better for this one. Give me 1 second, guys. Hold on. If I do it, so basically, the sketch is just like this, okay? It's not perfect, but it's close enough. So yeah, you have to know the difference between 1 over x and negative 1 over x. It's basically a reflection. They're reflections of each other, okay? And if you don't know how they look, just do a little timetable, or not a timetable, an XY table, and do a little sketch, just like I did here, okay? Because I know it takes a little bit of time to remember these. Even for me, today, like I still forget how it looks. So that's how it looks. That's how they both look, actually. And now we're gonna go ahead and do a problem where we want to find what the vertical and horizontal asymptotes are. Again, when you have a rational function, like anywhere on the graph, it doesn't really have to be that it, you know, one side like one side touches one part, and then it doesn't have to be like the 1 over x function. So one important thing to note, okay, let me bring it a little bit closer. So one thing to note is that this vertical line here is called a vertical asymptote. And this horizontal line here is called the horizontal asymptote, okay? That is how they look on the graph. What those mean, it means that it is a line which the graph is approaching, but it never touches, okay? And algebraically, you can find both. We're going to do an example right now on how to do that. So, give me a second, guys. Let me just make sure again that okay. Okay, sorry about that, guys. I really want to make sure that it's working well, the stream. Give me a second. So now that we learned the shapes of how a positive rational function and a negative rational function look, we're going to review very quickly the difference between, what were they called? It was the difference between horizontal and vertical asymptotes. And since I already did it on a graph, I mean, it doesn't really, you know, I can sketch it very quickly, but what you want to remember is how to find them algebraically. This is something, for horizontal asymptotes, it's something that I forget literally all the time. So, okay, so, we're going to look at f of x equals x plus 6, or x minus 6. Let me write that again. Hopefully that's better. Hopefully y'all can see that better. X minus 6 over x plus 4, right? And god. Okay, so... Oh my goodness, I need to get a better camera because this one really sucks. So we're gonna find the vertical and horizontal asymptotes for both of these, or for this one. Remember the vertical asymptote? And let me just write something very quickly. Give me a second, guys. I'm just writing something down. Okay, so I hope y'all can read that. It's a little hard to read it. It says if we have a function of the form f of x equals ax plus b over cx plus d, then the vertical asymptote is defined as the x-intercept of the rational function, that is cx plus d equals 0, and we solve for our x by subtracting d on both sides. We get cx equals negative d, and so x equals negative d over c. Now, you don't have to remember that. You don't have to, like, I know that sounds very, 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 very confusing. Let me explain what I mean. All we're doing for the vertical asymptote is we're setting this equal to 0, and we're saying that x equals negative 4, okay? The vertical asymptote is x equals negative 4. That is all this means. That is all this is saying. So it's very important not to overanalyze it. And for horizontal asymptote is a little bit trickier. So, like I said, horizontal asymptote, that's the one that I always forget. But, I think I know how it is, but I forget. So if we have, for example, if we have 1 over x, the horizontal asymptote is y equals 0, right? And let's see. And I'm trying to think. So that's the horizontal asymptote. It's y equals 0 because x, so this, we have x to the 0 over x and x to the first power, right? Let me write that a little bit better. And we notice that, and let me actually use different colors. So we're going to say x to the 0 over x to the first power. Okay. Now, we have x to the m. This is of the form x to the m over x to the n, right? If m is less than n, the horizontal asymptote is y equals 0. Now, if we had something like x squared over x to the first power, right? If we have x squared over x to the first power, then we have, this is x, right? So I'm trying to think. Like we would have basically the horizontal asymptote. If we have, for example, let me just verify this very quickly because I really don't remember. Hold on. Give me a second, guys. Okay, so if I have something like this, there is no horizontal asymptote, right? So the horizontal asymptote would be neither or none, right? Because if we have the degree of the numerator is bigger than the degree of the denominator, that's going to give us x, right? So then that wouldn't be a horizontal asymptote, that would be a slant asymptote. Because remember, I mean, basically a slant asymptote only happens if we have x to the m over x to the n, and m is greater than n. So like, if I have x to the a over x to the b, and a is greater than b, right? Then we're going to have a slant asymptote. Right? That's how it would be. So that's how you find, like, that's how you find, like, that's how you would know, okay? So we're gonna go ahead and switch gears and do a problem where we basically, let's see. Let me just make sure I look at my list again because I don't remember exactly. So, oh, and the end behavior, this is just really quick. The end behavior just means if we have as x approaches 0 from the right, we want to look at how it approaches 0 from the right side, right? That's if we have as x approaches 0 from the right. Want to go over here like this. Like, what am I going to reach as I go from the right to 0? As x approaches 0 from the left, just means from this left side, as I move my pen closer and closer to 0, what am I getting to? So for example, f of x equals 1 over x. As x approaches 0 from the left side, y approaches, or f of x approaches negative infinity. As x approaches 0 from the right side, that means as x goes further and further from 0 to the right side, or to 0 from the right side, f of x approaches positive infinity, okay? That's what that means. Okay, so now we're going to go ahead and do adding and subtracting rational functions. So let me look to see if there's some problems we can do. We're going to do this very slowly, so we're going to go from very, very easy to a little, like, we're going to go to very, very hard, basically. That's what I'm trying to say. Let's say we have something like 1 over x plus, let me go ahead and make that bigger. One over x plus 1/3, right? You can use, I think it's called the butterfly rule. That's what they called it, apparently, when I was looking it up yesterday. This rule here. You can use that. Or you can also do it vertically. So 1 over x, basically 1 over x plus 1 over 3. And then you ask yourself, well, how do I go from, like, how do I get my x and 3 the same, you know? Like, how do I make them a common denominator? Well, if you really don't know how to make them common, the best thing to do in this situation is to multiply them together. So basically, I can say that this equals 3x, and this can also equal 3x, because I can say, well, to go from 3 to x, we have times x, and then what I do to the bottom, I do to the top, so then I say 1 times x, so this is just x, and then I go from x to 3x, I go times 3, and then what I do to the bottom, I do to the top, so then I say 1 times 3, so then I have 1 times 3, and then I have 1 times 3 plus 1 times x all over 3x, and this just gives me 3 plus x over 3x. So then this is just equal to x plus 3 over 3x. Okay. That's a very simple one, okay? I'm trying to think of another one. So this is just like adding fractions if you think about it, because you're doing the common denominator and you're just simplifying it. That's what it is. Let me see if I can look on the textbook that I found. Hold on. Give me a second, guys. Hold on. I'm looking. So I can't find it. Okay. Oh, and one more thing. I forgot to do this. Oh my goodness. The domain and range of a rational function. So we're gonna look at a few problems like those. Hold on. So now that we've learned vertical and horizontal asymptotes, we can do a problem with domain and range. So we're going to do a problem that says find the domain of f of x equals 4x over 5 times x minus 1 times x minus 5, right? So you want to include all the real numbers except the denominator, because the denominator cannot equal 0. So you're gonna say that the domain is all real numbers such that x minus 1, or rather, hold on. Five times x minus 1 times x minus 5 cannot equal 0. Okay. From there, you're going to solve the problem. You're going to say 5 times x minus 1 times x minus 5 cannot equal 0. And you just solve it using you just solve it using the zero products property. So basically you would divide 5, right? You would have x minus 1 times x minus 5 equals 0. So then we have x minus 1 equals 0, or x minus 5 equals 0. This would be plus 1 on both sides. X equals 1, right? And then plus 5 on both sides, we would get x equals 5. Okay? So then you say, okay, well, x, since we had, so it's cannot equal actually. Cannot equal. X cannot equal 1, x cannot equal 5. Right? So we have x cannot equal 1, x cannot equal 5. Now, they will, it depends on how they want it. So some professors can accept this. You can say all real numbers such that x does not equal 1, x does not equal 5. Or you can just say x does not equal 1, x does not equal 5. But some other professors or some teachers are a little more strict. They would want you to learn how to put it in interval notation. And I don't know if they do union symbol in algebra or not. But union symbol just joins two like intervals together. So for example, if I have something like and this is apart from the problem, but if I have something like this where I say, well, we have a value going from negative infinity to negative 4. And then you would say, well, and then, you know, we're kind of shading like this, right? But then we also have another one that's like from 3, right? And we say, oh, this one is, we'll just say it's a closed circle or a dot right here. And we're gonna say, well, this one is going from 3 to infinity, right? The way that you would say this is that in interval notation, or rather in I think it's basically as an interval, you would say, well, this would be negative 4, so then is or actually no, hold on. It would be as an interval, or in interval notation, excuse me, it would be negative infinity to negative 4 with a parentheses because you're not including 4 or negative 4, union bracket 3 to infinity. Okay, this would be the domain. This would be the interval. The union just means that it's joining another interval, which is from 3 to infinity. Think of it like this. If you want to think of it like that, you can. Like think of the union as going like that. And actually, it's not a parabola; it's a union. So you can think about it like that, but the union just means like, hey, we are joining two intervals together. So for the domain for this function, we have, so it goes negative infinity, and then we have to 1, and then we have from 1 to 5, right? And then we have from 5 to infinity. How would we write that, right? We would say, since we're not including 1 and we're not including 5, we can say negative infinity, the domain is negative infinity to 1 union 1 to 5 union 5 to infinity. Okay. The range, I'm trying to think. Since we have f of x equals 4x, and then we have 5 times x minus 1 times x minus 5, we would say, well, 5 times x minus 1 times x minus 5, this would be equivalent to saying ax over bx squared, right? This is a 1, this is a 2, which means that m, and if I put this as ax to the p power over bx to the q, right? That means that since p is less than q, we're gonna have basically the horizontal asymptote would be y equals 0. So the range would be from negative infinity, and I hope y'all can see that. The range would be from negative infinity to 0 union 0 to infinity. Okay, because it's telling us that it cannot reach 0 as the range, as the y, like the y cannot equal 0. If we could say the range is all real numbers such that y does not equal 0. Okay. Or actually, I'm wrong. Hold on. Let me see really quick, guys. Hold on. For the range, I think for the range it's a little bit different. Hold on. It's 4x divided by 5 times x minus 1 times x minus 5. Okay, actually, I'm correct. Never mind. I'm correct. So, basically, okay, so oh my goodness. I have not done these in so long. Hold on, guys. I'm looking. I'm looking. So, I mean, honestly, for this one, the range, I think the range, I'm trying to think, the range, because, so, the range, hold on, guys. Okay, sorry about that, guys. Hold on. Let me... let me go ahead and pause. I don't know if I can pause it, actually. Hold on. I don't think I can. Damn it. Because I know the resolution is, like, pretty bad. Give me a second, guys. I'm going to, okay. So, well, yeah, anyways, the rational function here, let me look it up, because I'm very curious as to what this would be. Hold on. 5, so we have 5, we have 5 times x minus 1 times, or sorry, 4x, excuse me, 4x over 5 times x minus 1 times x minus 5. Or let me go to Mathway, that one's better. It's 5 times x, so five times x minus 1 or sorry, 4x over x minus 1. So 4x over 5 times x minus 1 times x minus 5. Okay, so find the domain and range. That's what I was looking for. Okay. Okay, so obviously for the range, it's a lot more difficult for this one, so we're just gonna skip this problem because the range is a lot harder to find for this one. We're going to do a much easier one this time. So find the domain and range of f of x equals x minus 5 over x minus 7. Now, the domain, like I said, it's going to be all real numbers such that x does not equal 7, right? So that means in interval notation, we're going to have from negative infinity to 7, with parentheses on both sides because we're not including 7 in the interval, union 7 to infinity. Okay, with parentheses on 7. This would be the sorry guys. This would be the domain, right? And let me just make sure that okay. The range is, so we want to find the horizontal asymptote of this function. The horizontal asymptote, it's going to be y equals 1 because the top and bottom have the same power. So that means that y, so the range is all real numbers such that y cannot equal 1, right? So we have the range is going to be negative infinity to 1 union 1 to infinity. That's how it works. So kind of domain and range and horizontal and vertical asymptotes kind of go hand in hand. When you're doing domain and range, you need to know how to solve for vertical and horizontal asymptotes. Let me go ahead and I need to fix the resolution of the camera because literally I don't know why it's like this. I really don't know why it's like this. It shouldn't be like this. Because it's kind of blurry and you can't really see what I'm writing. Okay guys, I'm gonna come back. So give me just a few minutes. I'm gonna stop the stream, but I'm gonna continue again afterwards. So after I fix this little problem, so give me just a few seconds. I will